QGIS, and I'm going to save the QGIS file in the particular folder that I created for the NDVI analysis. And here, first of all, here we have to create different subfolders like data, materials, QGIS, and results for store the data and any other materials when we are doing the projects, like uh, project project methodology if needed, and explanation of the project steps for the for the party you are sharing with, and QGIS for store the QGIS files, because when you are time to time click this button after saving the project, so it will save the layers in the QGIS file. So it will be great, it will be good to save time to time, because if you accidentally close or the program is accidentally stop working, it is better to save the QGIS files to start the work again easily just by clicking on the QGIS file saved in here. So I'm going to save the QGIS file as map1. You can use any preferable name as you wanted. I think NDVI analysis much better, NDVI. Okay, save, and it is same to NDVI, and I'm going to add the data in the raster data. I'm going to add the vector data to identify the study area we are working today with. So here I add the data already, so I'm gonna just refresh sometimes because the data is not available. Okay, just move to the project that we are working with. So that because that this is the project that I worked earlier, and now I'm moving to the new project, so the NDVI analysis. And in here, this is the study area I'm working with today. So this HP file, I'm going to add this one. So this is like a city in Brazil. So I'm going to show you adding the OS data. Okay, so you can see this is a study area in Brazil. Okay, so this is Brazil, and this is our study area. So I take a kind of small area because I just want to show you how to do the NDVI analysis. You can download the full data as I teach you in the last session from the USGS website. Now I'm going to add the needed bands. So for the NDVI analysis, I'm using the Sentinel-2 data and the um, uh, the needed bands. We need only two bands to do the NDVI analysis. It is band 8 and band 4 of the Sentinel data. So NIR, or the red band, is assigned for band 8 and band 4 in Sentinel data. So what is NIR and red band? So I'm at the raster data set. You have to go for the data source management in here and open that one and click on the raster and source as a raster data set, and click on this three dotted, and I have exported, I have created the files before to explain you how to do the NDVI analysis. If you need to check how to download this data, you can check my next video on how to download Sentinel-2 data in from USGS, or for some for or in the next series of how to use the Google Earth Engine for the projects. So here I'm going to open this data and add data. Here you can see the ESP4, as I mentioned, like it is the band 8, because I have renamed this the raster data, because to kind of like each of the operates in the raster calculator that I'm going to show you before, and also sometimes the bigger names that kind of making issues when you're practically using GIS in projects. And here also I renamed the dataset. Okay, so let me some kind of do some explanation for the datasets. So the ESP8 or the NIR band or the band 8. Actually, the correct word is band 8 in in the Sentinel-2 data. So it is approximately the wavelength of the band 8 is 842 nanometers, and resolution is 10 meters. You can see the how the high resolution is this data. It is 10-meter data, so it is kind of it is a high resolution data actually. So as I mentioned before, the Sentinel-2 mission is to monitor the Earth's surface with high resolution optical imagery. So it is a proof of that high resolution data set. So the NIR can identify the water bodies easily. You can see the water body here is in dark color. So you can identify the water bodies using along with the NIR band, and also considering the cloud penetration, it is the band is providing better penetration through clouds. So it is also good to cloud penetration. And the band 4, you can see band 4, it is the wavelength of the band 4 is approximately 665 nanometers, and the resolution is 10 meters, and this can be used to identify the vegetation cover, as I'm going to do in the next analysis of the raster calculator, and the land cover classification also. So let's move to the NDVI analysis. Without further talking, I'm going to use the tool in QGIS. You can, if the toolbox is not present here, you can go to the processing and open the toolbox here, and you need the tool called raster calculator here. Open the raster calculator, and you have to first input the layers that you need to do the analysis. So to do the NDVI analysis, the equation is this is the equation that you need to do the NDVI analysis. I'm going to kind of highlight it. So you have to reduce the red band from NIR band and divided by the NIR plus red band. So this is the equation. I'm going to show you how to add this data in the raster calculator and do the NDVI analysis easily. So this is kind of easy process, so no need to worry about that one. Anyway, I'm going to add these two layers, and have to add files. Click on this. Click on OK, and these two inputs selected. You can see that one. And I'm going to, in the expression, I'm going to add the raster equation. So the raster equation, or the equation to do the NDVI analysis is NIR minus red divided by NIR plus red. So NIR means the band 8. So I'm going to click on the band 8 and just reduce the band 4, and keep in mind to add the parentheses to do the correction, to do the raster equation correctly. Sometimes if we do not add these parentheses, the calculation equation is not working properly. So click on OK, and now the equation is set. Output extent, keep in mind to add the output extent means the study area we are working with. So here the study area is the Espírito Santo, the city in the Brazil. So I'm going to click on that one. Calculate from layer, so you can select on the Espírito Santo, and the output cell we have to we can give it to set automatically, but if you are considering NDVI for next project, you can have to select the cell output cell size. I'm going to keep it simple as default, and output CRS you can either select or keep it as default, but I'm going to select this one for the EPSG 4326 WG84. So it is the similar projection for these layers, and you can save the temporary file after the calculation, or you can save to file. I'm going to save because it will be is necessary if you are going to further analysis, or create a map, or you can share with someone. You have to save the result. So here I'm going to save result to the result folder. I'm going to save it as NDVI Espírito Santo. Okay, as the save type as the TIFF file. So save it, and we can click on this one to observe how the NDVI is processed after after finishing the calculation. So I'm going to run the tool. Okay, this in this time it is running perfectly. So if there is an error, you can see there is some kind of red message, red error warning when we appear here. You can search online or QGIS forums if you cannot understand the error, and to resolve the error yourself. So it is like all the QGIS field or GIS, remote sensing, any field, you have these errors can be happen. So don't panic in that situation. You have to try again. So it will be, you can be solved. Then I will close and go to observe the NDVI analysis. In here you can see the minimum NDVI analysis. Minimum NDVI value is minus 0.71, and it is mentioned is marked in black color. You can see those are the water areas. So that is actually it is kind of, you can identify it is correct, because the water you can not see the vegetation, so it is probably right. And I'm going to categorize these results. So let me share the standard categorization with you. In that case, we have to do the vegetation or the NDVI analysis in a scientific based method. So I'm going to use this classification here. So the low vegetation from 0.2 to 0.3, and moderate vegetation from 0.3 to 0.5, or the NDVI. The high vegetation values above the 0.5 values. So this is an example of a standard NDVI, but this can be changed from area to area. But when we consider in the Espírito Santo or area from the Brazil, maybe from a tropical environment, so this is kind of a standard method. So it is reference from the remote sensing of environment, or the ISPR Journal of Photogrammetry and Remote Sensing. So this is the standard method I'm going to use today to do that explanation. So I'm going to again go to the raster calculator and run this expression that I created before. So let's move to that one. Here I removed the unnecessary files and renamed them as NDVI2 for the next analysis, because sometimes it is better to remove the unnecessary files and start a fresh start, to give a kind of fresh start for the raster calculator. And I'm going to use the same impression here. Okay, and so this is the expression that I'm using. So NDVI values that are below 0.1 is indicated as water, and the next classes are decided as like here. So this is the classification I'm using, the standard classification. So outputs extent, I am going to output extent as same as in the Espírito Santo, and the default project as mentioned, so the optional one, but I choose this as to WS94, and you will save to file NDVI. Okay, so save and run the file. So this is the expression that I'm going to use for the NDVI classification. So like as I mentioned before, this is the expression that is the standard expression, standard classification, and so I convert it to NDVI standard classification expression that I can run in QGIS raster calculator. So let's move to the raster calculator and run this expression that you can identify the area, the raster values that are lower than the 0.1 as water, and the raster values between 0.1 and 0.2 are bare land. Likewise, you can observe or you can see how the standard classification is converted into a classification expression that can be run in QGIS for the classification. And here I am going to select the NDVI layer, classified layer, and just copy and paste the raster expression here. You can customize this expression as how your NDVI raster file is named. You can just customize here, and if any error occurred, you have to understand what is the error and try to rebuild the expression and run it again and again until you get the correct result. So here I just get this similar output extent, so because I already created that one, and I'm going to save to the file that NDVI classify to, because this one is not correct that I tried earlier before teaching you the correct expression. So I'm going to run the file. Yes, it is right, and I'm going to do the classification here. I'm going to the selected values and classify. There are 5 values that I created, so you can see each number 1, 2, 3 and 4, 5 are here classified. So it is important to notice these values before you are doing the calculator. You can see the similar values here. Okay, so without these values you can't assign values, you can't actually reclassify the NDVI classification or any other raster classification correctly. Here I am going to change the color to blue color, because in 5 we are going to show how the water, and the next in 1, sorry, I did a mistake here. So you have to here can select the color here and okay, and 1, then 2 is for the bare land. For bare land, I think suitable color is kind of this one is okay. You can see this color is changing here, the current one. This kind of suitable, okay, I think. And the next one is low vegetation. It's big green but not smart green, I think. This is okay. Okay, so the 4th one is the moderate vegetation. It's also green but not too much green, and this is okay. And 5 is high vegetation, so go to more green and okay, and go to apply, and you can see the area changes here. So you can see how the water is defined clearly, and the bare land also is available, and high vegetation areas here. And if you NDVI classification here is been done, and you can also symbolize this area. Okay, change the label here. You can see this water, and the next one is bare land. Okay, so okay, the bare land, and the next one is we'll see the low vegetation. And the moderate vegetation. And the high vegetation part. Okay, so it is going to see the legend here, and that's it, the NDVI classification. So so this is the expected result. So I'm going to stop here, and we'll meet in the next session, and thank you very much.